Chapter 2, Electrical Laws and Circuits. So, folks, I'm not an electronic technician by any means. I have no training or college education in it whatsoever. All I have is just a little bit of ham radio from years ago that I just kind of threw away, and now I'm trying to get back again. But this is good. This is good to read, and I'm going to spend more time with this. But since this is radio electronics, electronics that refers to radio, I like how they start with electric and magnetic fields, because we're transmitting and receiving radio waves. So this first part about lines of force, electromagnetic fields, lines of force, flux lines, electromagnetic waves. Probably already said that, but I said it again. I remember in school, grade school, or was it high school, but when we took a class in electronics, I think it was science, class, the first thing they talked about were basic things. What's a conductor? What's an insulator? Well, a conductor, of course, is metal, carbon, and acids. Didn't know that. Insulators, dry air, wood, porcelain, textiles, glass, rubber, and resins. Okay, I'm probably wrong about this, but you know when you buy computers nowadays, the processor speed is rated in frequency, gigahertz, hertz. You know, hertz is basically the same thing as a cycle. They just changed the name to Hurt from cycle. I think it's named after a guy, Mr. Hurt, I don't know. But this is one cycle. It's a 360-degree deal. Positive down to negative, back to positive, 360 degrees. That's one cycle. So when they say, 10 gigahertz, it's 10,000, or 10 gigacycles, same thing. Anyway, you guys probably all know that. I don't know. I probably didn't even explain that right. So what I like about this book is that it just explains this theory, but I need to read this a few times to understand what they're talking about, especially when they talk about wavelength and what that means and the definition of. It just keeps going and building on basic theory, kind of giving you a really good foundation of what these terms mean, and it's pretty cool. After all of that, then we get to Ohm's Law. E equals I times R. Voltage equals current times resistance. And then you can interchange those around by substitution to figure out any one of these. If you have two of these, you can figure out the other one. One time I did this on a job I was working on. It was a big power substation. In the drawings, there was a picture of a big giant circuit breaker running at about 150 kV. I think 3,000 amps. Oh, that's 400 megawatts. It was unreal when I just kind of did Ohm's Law. So that stuck in my mind, and I was able to just kind of amuse myself by that little calculation. Whether it was right or not, I don't know. And more of this great basic foundation theory, the conversion table for fractional multiple units, such as micro, milli, kilo, mega, mega ohms, kilo ohms, whatever, microfarads, and what that means. This is all like stuff you learned in school back in the good old days. Resistors in series versus resistors in parallel. Now we're going on a voltage drop, on and on and on. Gives you examples of what you can kind of calculate what resistors do in parallel as opposed to resistors in series. I think there was some study I was doing when I was younger where they would have like a little math tests on different circuits, and what's the total ohms on this kind of a circuit versus this circuit, and you can basically run through and do that. And so that's what I remember of just going through this stuff. Like I say, I'm not going to go through. This is your foundation, the basic beginnings of all this stuff, and it's going to build, get more and more and more complex. The book does a great job in laying this out as far as I can tell. And now we're going into capacitors, resistors, capacitors, probably inductance next. But again, this is, when I was learning ham radio, it was the 1980s. And this stuff was what you kind of started out here learning, all these basic theory. And here's capacitors, here's little pictures of it. 1950, great photos, guys, awesome. I remember I started getting lost when he started talking about capacitors, and it got more and more complex, and it was like, okay, I should have paid attention and somehow retained what I've learned before, the basic building blocks of all this theory. But I know now that as time's gone on, as I know myself and reading and trying to study, it takes me a while to comprehend what the hell I'm reading and some of this theory. But I think it's a must to just reread it and reread it, maybe ask some questions until bang, finally it dawns on you. Oh, that's what they mean. Inductance really blew my mind too when I was trying to learn this stuff. So, I'm just kind of rolling through all this, not really reading it, coils. And I do believe that going back and getting more, like reading this again, this is probably, this book, I would read this over and over to kind of get the idea of what they're talking about. Transformer, oh yeah. So way back in 1978 or 77 maybe, when I was studying, trying to get my novice license, they do go through some of this theory at more of a basic level. And then when I went to the general class, it got more intense. And I think it took me, I don't think I passed it on the first time, but I'm kind of wondering if I would have had this handbook right next to my general class study manual and being able to maybe look up the stuff and getting more of more of an explanation of what I was trying to learn on a more basic level, starting for the general class and the novice class. Maybe that would have helped me a little more. I don't know. So I think looking back, it was the novice class, the general class, the tech, advanced, and extra. Those were the classes of amateur radio license you could get. But what's in this handbook is, and I've always noticed it gets complex real quick. So just a general or just a gradual, starting from the novice class, working through your licenses, the classes, learning the theory based on that level of licensing was a good way to kind of build up and learn more and more as you go along. So, it's too bad they've kind of gotten rid of a few things. I don't think, is there an advanced class anymore? I don't think, but there were levels of novice. Let's see, it was novice, tech, general, advanced, extra. So you would build these tiers on studying and passing your exams until you get to the extra class. And by then, I would think this handbook would seem more comprehensible at that point, because you know everything, or you're supposed to know everything. I don't know. So I would say this is just about all I can say about chapter 2 and all the information in here, because there's a lot in here to read and to understand. And I don't have time to even comprehend this with myself in one sitting or even in a little video like this. But I just wanted to show you what's in chapter 2 and just how deep this theory is. This is 1950, but these people had a lot of this stuff figured out. Next will be chapter 3, vacuum tube principles. Thanks for watching, folks.